So in the first part of the chapter, we talked all about real numbers. Now we're going to get to graphing with imaginary numbers, okay? So we're going to notice some things. First thing I want to focus on is the vertex. So what is the vertex here versus here versus here? Oh, and can you do me a favor and change that to +4, please? I didn't like the +3. So I want you to see, in this case, the vertex. Hopefully you remember you do the opposite, but then straight shooter. Opposite, but then there's nothing on the outside. Opposite, straight shooter. So right now we've got 2, 1, 2, 3, 4, 2, -4. We've got 2, 0. And we've got 2, +4. Okay, I might be off there. And it's squared. So since it's squared, it's a U. My U is either going to go up or my U is going to go down. It's all based on the front. The front is positive, so all of them are going to go up. If I was to graph this, a rough sketch, okay, how many roots do I have? 1, 2. Okay, if I graph here and I go up, how many roots do I have? 1. Oh, and I have it right there. If I graph this and I graph it up, how many roots do I have? I have 0. Okay, so we can describe them in different ways. So in this one, if I graphed this on Desmos, which I think I did, if you look here, sometimes the brightness changes. The roots are, remember how you compress it? You compress it and it tells you the roots. So let me erase this, make it in pen so that I can more specifically 0, 0 and 4, 0. And those are both 2 real roots. Okay, so there we go. Then this one, it's already touching the x-axis, so that is my root. Let me erase that. We'll just rough sketch it. It's okay, I won't tell. So that means what are the roots? We have 1 root, so that means we have 1 real root. But remember, notice how this one went through. This one went through, this one bounced. Okay. This one over here, so let me do this roots in pink. I love myself some pink. Okay. There we go. And here, there are no real roots. So what are the real roots right now? We don't know what they are, because there are no real roots, which means there will be imaginary roots. So here I've got 1, 2 roots. Here I've got 1 and the bounce makes 2. Okay. For this one, I want to remind you, if I was to find the roots, what do? I set it equal to 0. So I just want to show you. First thing I do, subtract 4. What do I do now? Square root, square root. Ah, we have a negative. Anytime we have a negative, what letter of the alphabet am I thinking of? I. And the square root of 4 is 2. So it's x plus 2 equals plus or minus 2i. So x equals -2 plus or minus 2i. So these are my roots. I now have 2 imaginary roots. Okay? So let's extend to do that for this one. So they want us to find the roots. If I'm going to find the roots, it told us over here, set the y equal to 0. So I will do that. 0 equals. Let's rough sketch it actually to see how many roots I would have. If I'm going to graph this, what would be my vertex? -5, 9. So what do you think? Am I going to have 2 real roots, 1 real root with a bounce, or 2 imaginary roots? Okay, it's not crossing the x-axis, so I should have imaginary roots. Subtract 9. Square root, square root. Ah, anytime I have a negative, what letter of the alphabet am I thinking of? I. And don't forget plus or minus. So if I was to describe this, this would be 2 imaginary roots. Okay? This one, I don't know about this one yet because this isn't in vertex form. This one is in standard form. So I would have to find the vertex and then figure out if it crosses the x-axis. But I don't want to do that because I don't want to put it in vertex form. But if you remember, some people go, well, how did you find the vertex again? That's when I solved by completing the square. So I would move the 9 over. And then I would complete the square. Remember, I'd put this here. I'd split that. X, x, -2, -2. Negative 2 times 2 is, so I go plus 4. Let me take that just to kind of remind you. Plus 4, plus 4. And then I would get negative 5 equals, take the outside here, and that's what goes on the right. And if I was to put it in vertex form, I move the 5 over. So if I was to rough sketch this, my vertex is 2, 5. And this graph is going up. So some of you go, but I don't want to do all that. Well, I'm trying to find the roots, aren't I? If I'm trying to find the roots, couldn't I have solved by completing the square, which a lot of you like to do? Now take this, set it equal to, take this, and now square root. And then I would be left with, let me move this a little bit over, plus or minus I, you cannot take the square root of 5, equals x minus 2. X equals 2 plus or minus I rad 5. So I have 2 imaginary roots. So I can solve by completing the square, but some of you find comfort in the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So if I do this right, I should get the same thing. All right, let's see. So my a is 1, my b is negative 4, and my c is 9. This should all be review, so if I'm going too quickly, I need you to text me and say, Miss Rifkin, I need help with this one. You went a little bit fast on the video, and I forgot because I am human, but I appreciate that you're going to help me, okay? And I have no problems. I don't mind helping you. But if you think you're going to figure it out yourself and you still don't, you need to figure out what you can do so that you're good to go. 20, birthday cake. Circle the double. That's what goes on the outside. Ah, there's an I. Rad 5 plus or minus. Negative of a negative is 4 over 2. I can divide all of these by 2. So this would be 2, 1, 1, which is 2 plus or minus I rad 5, which is what I got right here. Solve it by completing the square? Great. Solve it by the quadratic formula? Great. What's the advantage of solving by completing the square? The advantage of doing that is it lends itself to just move this over to put it in vertex form. So this to me is more practical for more purposes, okay? Do either of them graph? No, they do not graph the x or intersect the x-axis, and they are imaginary, okay? I should probably learn how to spell imaginary. Okay. Let's see. I'm not sure I care about that, so let's just turn the page. All right. In these 4 problems here, what they want you to do is take these and add them, and then take these and multiply them. So I'm going to go 2 plus I plus 2 minus I. Well, we remember how to add. 2 plus 2, 4. And then I minus I, oh, it's gone. So that's just 4. And when they ask us to multiply it, what they're asking us to do is box it out. 2 plus I, 2 minus I. Remember what I squared means. I squared means negative 1, but you have another negative, which means now that's actually positive 1. 2i minus 2i is gone, and 4 plus 1 is 5. Okay, let's do this one. Letter B, 3 plus 3 is 6. Negative 5 plus 5, gone. Multiply, do the box. Some of you will start seeing a pattern, which is what I want you to see. Some of you will not see the pattern, which is fine because you have the box. But some of you will see a little way to maybe even get this answer in your head. Show work, of course, on your quiz. I squared is negative 1 times negative 25 is positive 25 plus 9 is 34. 15 minus 15 is gone. Okay, I'm going to skip this one. You get this. Okay, but I want to do this one. So 1 plus 1 is 2, and I rad 3 minus I rad 3 is 0. But I want to do the box because we haven't been dealing with square roots or radicals. So 1 plus I rad 3, 1 minus I rad 3. 1 times 1 is 1. Okay? 1 times negative I rad 3 is negative I rad 3. This is positive I rad 3. Cancel, cancel. I squared rad 3 squared. What is I squared? Negative 1. What is the square root of 3 squared? 3. Because the square root of 3 times the square root of 3 is the square root of 9, which is 3. Which means this whole thing is negative 3 plus 1 is negative 2. Okay? All right, so now in these problems, what we're going to do is sometimes we're going to have real roots, sometimes we're going to have imaginary roots, sometimes we're going to have both, and we need to get the equation in standard form. Okay? So the first thing is we're going to go backwards. So always do the opposite. X plus 3. X minus 4. Oh, cool. That's in factored form. Now, I want to remind you about the difference between this section and... It's always fun to try to find things. Remember here, I know it's a hot mess, we had to specifically find the A, but whether we had the A or we didn't, the roots were negative 2 and 2. But now the roots are still negative 2 and 2. So does the vertical stretch or compression affect the roots? No, it doesn't, okay? So this is a generic equation. If I gave you another point and I said, oh, the point is negative 2, 6, you would have to plug in negative 2 for X, 6 for Y, solve for A, and put that in front as a vertical stretch or compression. But for these problems, just give me the generic factored form and standard form. If I'm going to put it in standard form, I've got to box this out. X plus 3, X minus 4. You box it out, tell me the answer. Okay, and it's Y equals X squared minus X minus 12. All right, this time, same thing. X minus 5, X minus 1/2. But you cannot write 1/2, okay? I will not be okay with that, so you're going to write it so that there are no fractions, so this stays the same. And it's going to be 2x minus 1. And some of you go, how did you know that? Okay, well, I know if I set 2x minus 1 equal to 0, add 1, divide by 2, and it works. And some of you go, but you know that. How do I know that? Well, let's look at the x minus 1/2. What makes it a fraction? This 2 on the bottom. If this 2 wasn't there, then it would just be x minus 1. So instead of dividing by 2, why don't I multiply that by 2? Let's keep the 1 in its spot. The issue is usually the bottom number. So now I go y equals x minus 5, 2x minus 1. How do I put it in standard form? You box it out. I get 2x squared minus 11x plus 5. Okay? This is a quadratic. 2 real roots. 2 real roots. Quadratic, quadratic. Okay? Let's look over here. This one. You can write x minus 0, but x minus 0 is just x. You don't need the minus 0. This is x minus 3/4, but we don't write it as 3/4. So it's 4x minus 3. Throw that up there. And this would be x plus 6. So in factored form, done. This has 3 real roots. Okay? And the x-intercept is the same as the y-intercept because it crosses at 0. All right, the next thing is they want us to multiply it out. There's different ways to do this. You could box this out and then multiply by x, or you can distribute that in there and then box it out. So I think I'm just going to do it that way. That way we all get the same answer for what we get the same answer anyways. So do me a favor, box it out. What do you get? So this jumped, so I will go over it in the next video. I just have a max.